All right, so in this example here, Chemistry 30, solubility example, we're talking about the hardness of water. And this is an example that's in your package, and I'm going to give you sort of a guided tour through this question. So this is a real-life example where if you're living, especially in a place where you have hard water, it's an issue. Okay, the taste, how it affects the fixtures, the pipes, your kettle or whatever. You get discoloration in the bathtub and the toilet and all that sort of stuff. So hard water can cause discoloration, and it could damage your some of your appliances and things. So usually we're in the city here. Usually in the city our water isn't that bad, although most of you probably still have a water softener. So what the water softener does is it takes some of these free metal ions out of the water. So what makes water hard is the presence of ions such as magnesium and calcium. Sometimes there's iron and different things in there as well, of course. One way of softening water is to remove these ions by adding an ion that produces an insoluble precipitate. So this is exactly what we've been doing in our solubility unit, right? We want to add a common ion, not so much a common, but we want to add an ion that will help make an insoluble precipitate. Okay, so what we want to do is we want to add this right here. See this? Sodium carbonate. Now, sodium carbonate is very soluble.
This is just an announcement for staff helping with the...
All right, as we continue. One of the ways you can precipitate these ions is by adding Na2CO3. This is very soluble and will give us sodium ions and carbonate ions. Now, the sodium ions, not such a big deal because that's a positive ion just like these are, but the carbonate is a 2- ion, and calcium carbonate and magnesium carbonate are both very insoluble compounds. So basically this carbonate is going to be released into the water, and it's going to go around fishing for calcium and magnesium ions to precipitate with. And so then all these free ions will form a precipitate. It's going to be very small, and on that precipitate will be removed from the water. So the water will be minus a lot of these ions. So that's the whole idea. So the question is set up like this. If tap water has this concentration of calcium ions, okay, we'll just deal with calcium for now. Calculate the maximum mass of this sodium carbonate, right here, that must be added to a tub, so we're talking about a bathtub of 25 liters of water, without causing any precipitation. So what that means is let's saturate the solution with just enough ions to match up with all of this calcium to soften that tub full of water, okay? So we're going to use the KSP for calcium carbonate. We're going to use the given concentration for calcium, and we're going to find out how much carbonate ion, first of all, we would need. And then we'll go backwards to find out how much sodium carbonate we will need to give us that amount of carbonate ion. So the steps here, okay, so I've given you some steps here. Question number 1 to answer in solving this. What's the concentration of carbonate ion using the calcium concentration and the KSP? So the KSP is, 4.8 times 10 to the negative 9. And that's going to come from the calcium ion concentration and the carbonate ion concentration. So calcium carbonate, right, looks like this. It's just a 1 to 1 to 1, right? And that's what it looks like, going either way, right? So it's a 1 to 1 to 1. And so we're given calcium ion concentration, aren't we? That's the one we're given, and it's 0.004, right? So right away, we can tell how much carbonate ion we're going to need to match up exactly with the calcium ion that's making the water very hard. Does everyone understand that so far? So how do we do this? This is just an unknown. We're going to divide by 0.004, right? Okay. So the concentration of carbonate ion here is going to be, looks like it should be something like 1.2 times 10 to the negative 6. Did you guys get that? All right. And that's going to be moles per liter. That's concentration, because KSP deals with concentrations. All right. So knowing this, the second sort of level here is to say, okay, well, this is how much ion we need, and that's going to come from sodium carbonate, right? So we're working backwards here now to get to the sodium carbonate. So what is the concentration of sodium carbonate based on the concentration of the carbonate ion? Well, if we write that little dissociation equation now, Na2CO3, that's the sodium carbonate, and it's going to give us 2 Nas plus 1 carbonate, right? A 1 to 2 to 1 molar ratio. So guess what? I know the concentration here. It's 1.2 times 10 to the negative 6 molar. This would be a 2 times that, and this is going to be a 1 times that, or the exact same. So all of a sudden, we've now found exactly the concentration we need. This many moles per 1 liter. You see that? Because it's a 1 to 1 ratio of yielding carbonate ions there. So again, we're just working backwards. So now we're getting pretty close to finding out how much NaCO3. So the next step here, once we've got that number, is how many moles of sodium carbonate are in 25 liters of solution. So this is this many moles in 1 liter. So let's take this and we're going to multiply it by 25. Right? Moles in 1 liter times 25 liters. And so that number should be 3 times 10 to the negative 5. Does that look good? And that's going to be moles of Na2CO3. So now we're really close, right? That's how many moles we need exactly for this bathtub. And so now, this is supposed to be sodium, not socium. Not sure what that is. Socium, soaking in the bathtub maybe. How many grams of sodium carbonate are there in 25 liters? So here we go. We've got this many moles. We convert from moles to grams. Okay? And of course we need the grams per mole for sodium carbonate, which is, so we're going to go 3 times 10 to the negative 5 times, we have 2 sodiums, plus carbon, plus 3 oxygens. Of course this is moles, and this is grams per mole. So the moles are going to cancel out. And I guess this is what you should end up with as your answer there. Okay. So let's just review this real quickly, 10-second review. Okay, you've got hard water, you've got an ion that's causing the hardness here, and that ion is at this concentration. You want to match up another ion that's going to precipitate this ion that's causing the hardness out of solution. And so you want to find out, hey, calcium carbonate is the solid that we want. So here's the calcium, what's the carbonate ion? Well, there's your concentration of carbonate ion. Once you get the concentration of a carbonate ion, you're going to say, well, that's got to come from the sodium carbonate, and so that's a 1-to-1 ratio, which is the exact same concentration. So now we know how many moles for every 1 liter we need. Well, it's a 25-liter bathtub, so we need this many moles per 1 liter. We've got to multiply that by 25 to get the right number of moles to match up with our ion that's causing the problem. And so then that mole, now, moles doesn't really help us too much. We're looking for mass of this stuff. And so you would need very small amount, but 0.003 grams of this common washing soda would soften up the water without causing any precipitate. Okay? So that's that. That's that question. Any questions from you guys?